it, record this, shrink it. It's blown up a little too much. All right. This is a perfect problem for what?
I'm sorry, what was the question?
This is a perfect problem
Mm-hmm.
for which technique?
Well, I'm guessing just putting in numbers, right?
Exactly, yes, picking numbers. So let's pick any A that's between 0 and 1.
Okay.
Give me one.
So it has to be positive,
Mm-hmm.
and it could be a fraction or a decimal.
It's got to be between 0 and 1. Let's keep things as fractions. Fractions are actually easier to work with than decimals by a lot.
So let's do a half.
Okay. And pick a B.
So B is greater than 1?
Uh-huh.
2.
All right. Now, let's just go through each of these.
Mm-hmm.
Is 1 less than 1 divided by 1/2? Is that a true statement?
Yes.
Okay. Is that less than 1 divided by 2?
Wait a minute, that's 1/2.
Correct.
So that's not true.
Okay. Let's go to the next one. We got 1 divided by 1/2. First of all, is that less than 1?
No.
That's not true. Let's go down to C. We got 1 divided by 1/2. Is that less than 1 divided by 2?
No.
Let's go to D. Is 1 divided by 2 less than 1?
Yes.
Is it less than 1 divided by 1/2?
Yes.
That's our answer.
Cool.
Okay, and the only real thing here is how to divide by fractions. In other words, what you really had to know was that that was equal to 2.
Right.
Okay, once you knew that, the rest of the problem unfolded perfectly. This is not a hard one. This is an easy one because as all you had to do is pick any two numbers and you're going to come up with the right answer if you just go through it.
Mm-hmm.
This one. This is one of those geometry problems that I had to stare at a long time. Okay. Here's the reason. First of all, in a typical shaded region problem, let's say you wanted to find out the area of the shaded region on the left.
Uh-huh.
These are almost, and by almost I mean 98% of the time, are subtraction problems. We don't have the math available to tell us what the area of those 3 sections are. What we do have is the math to tell us the area of the outside circle and the area of the triangle. And the area of the outside circle minus the area of the triangle is the area of the shaded region.
Okay.
Okay. And that is the way most shaded region problems look.
Okay.
They are subtraction problems. So when I first looked at this, that was my inclination, was to think of it as a subtraction problem. But then I realized that it was not. This is one of the few shaded region problems that you can actually figure out the area of the shaded region without, I mean, notice how hard it would be to do it the other way. Calculating the area of the two circles that overlap, that's not going to be any easy task. So
No.
let's see if we can deal with this triangle right here.
Okay.
You know that distance.
That's the radius.
Yes.
Okay. And that looks like equilateral triangles.
Well, you can't assume that.
I know.
However, there is a principle here that it took me a long time to see. And that surprised me because I'm very used to looking at it. Do we know what this distance is?
Oh. It's the radius.
Ah. In other words, all radiuses are equal. So
right.
That's R, that's R, that's R, and that's R. So you're
Correct.
right. We do have equilateral triangles. And if we just look at one of them, hold on. I want to draw a little bit bigger anyway.
I'm glad we don't get graded for our drawings on the GRE.
Sure. I wouldn't be able to do that. So if that's R, and that's R, and that's R, we should be able to figure out the area of this triangle in terms of R.
Mm-hmm.
So the first thing I would do is, since we know it's an equilateral, there is a formula for the area of an equilateral triangle.
Mm-hmm.
It's like square root of 3 over 4 times r squared.
Oh, really? Okay.
Yeah, but nobody remembers it, and it's not easy to come up with. So I actually think you're better off, I mean, unless you just want to add one more thing to memorize.
No.
You're better off doing it this way.
Okay.
The fact that this is an equilateral triangle means those are 60, that's 60.
And we got a 90.
And that's 30.
And two 30s.
Okay. Now let's look at this triangle right here. In other words, this one. That is a 30, 60, 90. That side is R. That side is 1/2 R. Correct?
Mm-hmm. Correct.
What is this side right here?
What are you pointing to?
The only unknown side, the vertical side there.
So if I recall correctly, isn't it a squared plus b squared equals c squared?
No? Well, yes it is, but it's actually easier to figure out if you remember your special 30, 60, 90 triangle.
Ah.
In other words, you're right. All right triangles follow the Pythagorean theorem. So I actually could figure that out, but it would be relatively hard because I have variables here and it's not going to be that easy. But if I know that all 30, 60 triangles have this relationship of their sides, and when I draw I call this the unit triangle.
Okay.
The side opposite 30 is 1, but you have to realize that any multiples of this work also. In other words, I can add an x there, an x there, and an x there. As long as the relationships are all the same, that's what's important. Now, I could also add r's. So just to be more clear, let me put an r there. Now, our triangle that we're interested in is what relative to this unit triangle? Is it bigger, smaller?
It's smaller if we're
By
using
how
the
much?
1 half.
Okay, so what do you suppose this vertical side is? It's not square root of 3r.
The square root of 3r divided by 2.
You got it. Now, we can figure out the area of that triangle. Area of triangles are 1/2 the base times the height. So what is the area of this? And we're only talking about that triangle right there.
Okay.
So what's the area of that triangle going to be? If it's 1/2 base times height. So
So base is 1/2 r.
1/2 r times the height, square root of 3 over 2r.
Why do you have 1/2 times 1/2? Oh, because the base is 1/2 r. Got it. Okay.
Right, okay. If I do this math, I get 1 over 8 square root of 3r.
1 over 8, I don't understand.
2 times 2 times 2.
Oh, because of the bottom, they're all the same?
No, because you multiply all three bottoms, regardless of what they are.
Oh, okay.
So it's 2 times 2 times 2, which is 8.
All right.
Multiply all three tops, which is 1 times root 3 times r.
Okay.
So it's r squared, excuse me. Square root of 3 over 8, r squared. Now, we figured out the area of one of those triangles. How many do we have?
We have 4.
I'm going to multiply that by 4. What I get is square root of 3.
Do you have to multiply the r squared too?
Well, in a way, that's my answer. When you
Okay.
have two things multiplied together, let's say I have b times c, and I multiply it by a, I multiply a times b, take the result, multiply it by c. That's just the way multiplication works. You have a bunch of things being multiplied. Okay, you with me?
Sorry, I had to close the door. Could you repeat that?
When you have a bunch of things multiplied, you multiply the
Yes.
a times the b, take the result, multiply it by c. You could also multiply a times c, take the result, multiply it by b. What
Right.
you don't do is multiply a times b and then multiply a times c again. In other words,
Okay.
do it one at a time, take your product, multiply by the next thing.
Got it.
So I have 4 times square root of 3 over 8 times r squared. That's square root of 3 over 2 r squared. Answer B.
So wait a minute. How did you just simplify to get the?
Yeah, I divided top and bottom by 4.
Okay. Now I understand. Got it.
Okay.
All right. Makes sense.
And I would say this is one of the more difficult problems.
Okay.
Definitely put it in the high-end range in terms of degree of difficulty. And like I said, I had to stare at this thing for 5 minutes before I even knew how to begin.
Mm-hmm.
Now, that's not the kind of problem you want on a test time. You don't have 5 minutes to stare at it. So
Nope.
this would maybe be one of those problems where I would put a double check mark by it and go back to it.
Okay.
And the double check mark it means extra hard.
Right.
If you're behind pace and you're about to put a double check mark by something, go ahead and guess, then you won't have to go back to it and guess.
Okay.
If you put a single check mark by it, that means it's hard, but maybe with a little more time, you might be able to come up with the answer. That's my method. And that way it allows you to distinguish between problems that it's worth coming back to and really problems that it's kind of a waste of time coming back to.
Right.
And if you leave those till the very end, then you have to take at least 5 seconds to make a guess. And there's a chance you won't actually even be able to make a guess, which would be horrible. That's the worst thing you can do. Making no guess is the same as getting the wrong answer.
That's true.
So if you make a guess, you at least have a 20% chance that you're going to get the thing right.
Right.
So you don't ever want to pass up possible guesses. All right. I love the way they add these little words in here that make you question exactly how to do it. First of all, if we have an inspector that's standing over this box and he reaches in and he grabs a light bulb with his left hand and he grabs a light bulb with his right hand. That's what's happening, correct?
Correct.
Is that any difference than him grabbing a bulb with his left hand, setting it aside, and then going into the remaining 19 bulbs and grabbing a bulb with his right hand?
Well, yeah.
No, I don't think it's any different.
No, it's not, because it's still
exactly the same.
He didn't put it back in the box.
Still getting the two same bulbs, right? And in fact, if you want to look at it, have him put his hands on both bulbs, withdraw the first one, take his hand off the second bulb, and then reach back in and grab the same bulb. Okay? So I don't think they're any different than drawing two light bulbs randomly from the box without replacement. That is the key. The fact that he's doing it simultaneously is the same as drawing two bulbs without replacement. He doesn't draw the first bulb, check it, put it back, and draw another bulb. He draws the first bulb, checks it, and draws the second bulb out of the remaining 19.
Right.
So, what is the probability that neither of the light bulbs will be defective? Well, the first bulb that he picks up, what's the chance that it is not defective? In other words, both bulbs have to be not defective.
So there are 20 and he takes one. Is it 1 out of 20?
No, there's 2 defective. So the very first time you pick a bulb, the odds are 1 out of 10 that it'll be defective. So the odds are 9 out of 10, or more specifically, let's write it so that it's a little more clear, it's 18 out of 20. In other words, out of the original 20 bulbs, 18 of them are not defective. So the probability that the first bulb he picks will not be defective is 18 out of 20.
Right.
Now, the second bulb. Once he's taken one bulb and shown that it is not defective, and that is a requirement for this answer, now you've got 19 bulbs left. How many are defective?
Well, if it's not, there still are 2 defective, right?
Exactly. So what is the odds that the second bulb he draws will also not be defective?
2 out of 20.
No, there's no
2 out of 19
bulbs. There's 19 bulbs.
2 out of 19.
Right, which means 17 out of 19 will be not defective.
Okay.
That's what they're asking. What's the probability that neither of the light bulbs selected will be defective? Well, that means that the first bulb has to be not defective. That's 18 out of 20. And it also means the second bulb has to be not defective. And since both of these have to happen, then you multiply.
Because it says and, right?
Well, because they both have to occur. Bye, come here. All right. My dog likes to go into these barking fits when I'm up here doing a session. So now, that's obviously not the answer we want to give. If this is a calculator problem, there actually is a little bit of a problem with you doing it on a calculator because you're going to get a decimal. Right?
Right.
So let's reduce it. That becomes 9/10, right?
Right.
And now 19 is a prime number, 17 is a prime number. I can't divide anything by 9 or 3, and I can't divide anything by 5 or 2 or 10. So all I got to do is multiply those together. That is 153, and you could do that on a calculator, and that's 190. You could do that on a calculator.
Right.
And that is a final answer. In other words, if you were to do the original 18 over 20 times 17 over 19, it's going to give you a decimal. It does you no good. You don't have the ability to convert that decimal to a fraction. So the only way to really do this problem is not necessarily without a calculator, but you got to come up with that fraction, which means you got to reduce the original fractions as much as possible.
Right.
Now, when I looked at that, I said to myself, well, that numerator, those add to 9. That means it's divisible by 9, and it's also divisible by 3. So the question is the denominator divisible by either 3 or 9? And the answer is no. If it's divisible by 9, those digits have to add to 9. And if it's divisible by 3, those digits have to add to something that is divisible by 3.
Right.
And that doesn't happen. So I'm going to declare that. And that makes sense that would not be simplifiable. If I start with 9 over 10 times 17 over 19, if that were simplifiable, I'd be able to simplify that.
Right.
And I can't. There's absolutely nothing I can divide top and bottom by. So therefore, I'm even more confident that that has to be correct. In other words, if this could be simplified, then this can be simplified by definition. You would not be able to come up with something like the bottom that can't be simplified, and after multiplying it together, it could be simplified. That doesn't happen.
Right.
All right, 25. And this is actually a problem where 25 is an easy question, which is pretty rare. It's the last question. You would expect the toughest question on the page to be 25.
Yeah, you would.
And it's not. So take that to heart. In other words, what that means is when you're taking this test, make sure you see all the questions. Don't.
Right, and I'm glad to, and I was happy to find out that they don't change as I go.
Yeah. Although, ideally, if you do well in the first section, then you are going to get harder questions on the second. But the value of answering a harder question is clearly going to be greater than the value of answering an easy question. So
Sure.
just because you're getting harder questions doesn't necessarily mean that's bad.
I know.
To your score. Your score could end
Well,
up higher by getting those
yeah.
harder questions.
I was just concerned that I couldn't go through as a strategy all the way through the test and see what's there. I was afraid that depending on how I answered,
Right.
all the rest of the questions were going to change, and that was freaking me out.
Right. Yeah, this whole strategy I've been giving you doesn't really apply, although I guess it applies to each part. In other words, when you're doing part one, you want to make sure you see all the questions before time runs out.
Right.
And then same with part two separately.
Right.
Okay. Number 25. Tell me what I should do every single step of the way.
For 25?
Yeah.
So a rectangular playground 24 meters wide that has the same area as a rectangular playground 64 meters long and 48 meters wide. So, if it has the same area, because 48 is double 24.
Like you're thinking. It's a hard way to do it, but it's the more sophisticated way to do it, but it's the quicker way to do it.
So half of 64 is 32, so multiply. So perimeter is when you add, right?
Right. You add all four sides.
So 30. So you just add 64 and 48.
Yeah.
And get 12, 130, wait, 112.
I think 112. Yeah. Actually, I think that's correct. Not sure I would have done it like that, although I do like your thinking. The first thing I would have done was draw a picture. 64 by 48. That's the one rectangle we know.
Mm-hmm.
With your calculator, tell me what that area is.
Oh, there's my calculator. 48 times 64 should
48.
be, 3,072.
Okay.
Oh, add. Wait a minute.
No, that's multiplying. You need to multiply. When you get area, you're multiplying.
Oh.
Okay?
Right, area, right.
Okay, so now we have another rectangle that's the same area, only it's only 24 meters wide. And you did correctly surmise that if it was half of 48, then this has to be double. So that has to be 128.
Oh, I wasn't doing it that way, but...
that looks like what you were doing. Oh, you cut that in half. You made that 32.
I did.
You got to double it. In other words, now with your calculator, here's what we know. In fact, let's just do this the traditional hard way. Let's assume we don't even recognize that 24 is half of 48. The thing I know is that the area of this rectangle is 3,072. So what is this dimension down here? Have to be. In other words,
so whatever times 24, excuse me, it'd have to be 3,072 divided by 24.
Good. What is that number?
Hold on. 128.
Exactly. Now you got there, you could have gotten there a little quicker by using your analysis. And that would have been really advantageous. It might have saved you 20 seconds. The problem is that when you use shortcuts like that, it's easy to make a mistake. And that's what you did.
Which I did.
Mistake. So we now know
304.
Yeah, 304. In other words, 2 widths plus 2 lengths is the perimeter. That's 24, that's 128, just add up all 4. So this was a good problem. I wonder if they intentionally made this half of that. I'm sure they did.
So that you could make the mistake I did.
Well, most people aren't going to make that mistake, though. Most people would double it, and it would be an advantage because they would instantly know that they were looking at a 24 by 128 rectangle. And you could get to 304 really quick knowing that. So if you take the shortcut you did, only do it correctly, this is a 30-second problem at most.
Right.
You do it the long way, which is kind of the way I did it, using a calculator, figuring out what the area is, and then figuring out what this side has to be. My way would have worked regardless of what the relationship was. In other words, my way would have worked if that was 23 meters.
Right.
Whereas your way works whenever it's a perfect multiple of one another, gives you a little bit of a speed advantage. But that's what they do that intentionally. That's not accidental.
Mm-hmm.
They want to give people who recognize stuff speed advantages. That's
right.
the point of the test. All right. Did you send the other one?
Yes, I did.
Okay. Let me pull it up here. Okay, should we just start upper left and go to the right, or?
Upper left is the end, so bottom left is, I think, the start.
Okay. I think I can just click on it. That looks like an end.
Oh, okay. Then yes, start from the bottom, the top of left.
Hold on. I closed out my Gmail accidentally. Huh. This is one aspect of Gmail that I don't particularly like, the way they separate it. All right. Let's have a look at that one, see what that is. That's number 4. So there's one before this.
Am I?
Let's look at this one here. That's 5. That's 7. They appear to go.
They're not larger.
Yeah, it doesn't really matter if we don't do the first one. Those are going to be the easy ones anyway.
Okay.
So we'll probably run into 1, 2, and 3 along the way here as we go through these, I'm guessing.
Right.
All right. The median income is $3,000 higher than the median income of college D graduates. And the 75th percentile of the incomes of the group of C graduates compared to the 75th percentile of the income of the group D. Well, right off the get-go, it certainly seems like group A would have to be higher. But this could be a trick question, right?
Right.
In other words, it seems, I mean, if I had 10 seconds to answer this, it would be quantity A immediately. College C, after all, they make $3,000 higher as a median income than college D graduates.
Right.
So the question is it possible for the 75th percentile to not be higher than the 75th percentile of college D? Hold on a second. I'm sorry, Carolyn. My TV, I got to turn it off, otherwise that noise is going to drive us crazy. Hold on. Sorry about that. I always forget Comcast. If it goes for like an hour on pause, it comes on its own.
Yeah. So I have a question for you about this problem.
Okay.
When it says 75th percentile, is it talking about the normal distribution, or is that something else?
Something else. If you were to have 100 people in Group C, and their incomes were 1,000, 2,000, 3,000, all the way up to 100,000.
Yeah.
Then the 75th percentile would be that guy makes 75,000.
Okay.
Okay. In other words, he is at the top of the third quartile.
Right.
Here's the thing. With this problem, the answer seems so obvious that my first effort is going to be to try to disprove it.
Okay.
If I can disprove it, then I instantly know the answer is D. As with so many of these questions, that's what you're always trying to do, is disprove it, okay? It's pretty unlikely that B would be greater than A, right? I mean,
right.
We don't really have to worry about that. But does A have to be bigger than B? Well, let me draw some numbers here for you. Hold on. In other words, it's pretty easy for me to come up with an example. I'm going to put 10 numbers over here. There's my salaries of the first group. The median, right there. The 75th percentile is right there. It's 3. Now over here, I'm going to put some more numbers. I'm going to put 10. There's my 10 numbers in Group D.
Are you just picking random numbers, or is there a logic?
What I'm trying to do is to find a situation where Group B has a higher 75th percentile than Group A.
Okay.
And I just found it because the 75th percentile in Group B is between 1 and 7, which is 4. The 75th percentile in Group A is 3. Even though the median in Group A is 2.5, the median in Group B is 1. Okay? So clearly the median of Group A is higher than the median of Group B. And whether it's $3,000 or not, I'm not sure that really matters.
Wait a minute. The median is
the middle number.
Yeah, I know that. But of the two numbers that you drew, you said the median in Group A was higher than the median in Group B?
Correct.
Based on what you drew?
Right, based on this sequence of numbers. In other words, we don't know what the numbers are. We don't know that they have to progress linearly or anything. Because all we know is that the median of Group A is higher than the median of Group B. And it says by 3,000, but that actually isn't important. what's important is that I find a group where the median of group A is higher than the median of group B, and yet the 75 percentile of group A is lower than the 75 percentile of group B.
So it's D.
It's D.
Okay.
Is that what you said was D?
Yes, D.
Yeah.
Dog.
And yeah, and that's usually the case, and that's why it's so, the very first thing you try to do is disprove what seems obvious.
Okay.
Because the moment you can disprove it, that means that we can't tell which is higher.
Correct.
Because clearly I could have picked a set of numbers where this number would have been higher than that number. All I got to do is use 3 there instead of 7. And now the 75th percentile on the right group is 2. On the left group, it's 3. So as long as I can come up with 2 different scenarios, then it's D automatically. I don't actually have to come up with 2 scenarios because it's quite clear that it would be very easy to come up with a scenario where the 75th percentile of A was greater than the 75th percentile of B. That is going to be easy to do, given the information they gave us. But proving the opposite is not so clear. Notice how skewed I had to make those numbers. I had to make the first 7 numbers all 1. And then I had to make the last 2 numbers big. Whereas over here, I made the first 9 numbers all small. And then the last number really big. And it really didn't require 100 there. I could have made that 4 and did the same thing.
Sure.
And in terms of whether it's 3,000 higher or not, well, what's this? 2.5 versus 1. Obviously, if I multiply everything by some number, I can get it to be 3,000 higher. It doesn't change anything else. So that effectively is unimportant.
Ah, got it.
The whole key is can you come up with a string of numbers where the median is greater than this, but the 75th percentile is less than this? And I did. Once you come up with it, that's all you need. On to the next. Let's see. I think that was the first page, yeah. Okay. The frequency distribution of 50 integer values varying from 1 to 6. That means you had 2 number 1s, you had 4 number 2s, you had 7 number 3s, and so forth.
Right.
If you add up all those numbers, they have to total 50. The numbers above the bars.
You add those up and they're
going to total.
Right.
Because it says the frequency distribution of 50 integers.
Right.
So the 50 is 6 plus 7, 13, 23, 49, 50. Okay?
Right.
Though you wouldn't want to spend the time doing that. That's not important. You just know that they do add up to 50.
Uh-huh.
Okay, the question is, which is bigger, the average value of the 50 values or the median? Well, it's a good question. It's also kind of hard. Let me see if I can come up with a good way of explaining. Well, first of all, let's kind of look at it. In other words, what does this mean? This means the frequency is we had a 2 and, excuse me, we had 2 1s, right?
Yes.
And we had 4 2s.
Mm-hmm.
The only problem with this technique is I can't draw out all 50 of them. It takes too long.
Right.
But I know that the arithmetic mean is the average of these 50 numbers that I would draw out.
Right.
And the last part of it, if I put dot, 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 I've got 11 sixes.
Mm-hmm.
Now, if I look at the median, what number is the median?
Well,
Is it the 25th? Is it the 26th?
since it's even, it's going to be in between
Okay. Let's
the
figure out what our 25th number is.
So 6, 13, 23, it's going to be a 5.
Correct. So a 5 is our, in fact, our 25th number, our 24th number, and our 26th number are going to be 5s.
Mm-hmm.
Because the last 27 numbers are 5s and 6s.
Right.
So the last 27, that would make that the 23rd number, that the 24th number, that the 25th number. I'm not even sure I need that analysis. Let's do away with that. I'm not sure that's accurate anyway. But definitely our median is 5.
Mm-hmm.
What do you think our mean is? Less than 5?
More than that.
5.
I'm guessing it's more.
Yeah, because we're right skewed.
Because you have 66 and 40 and 21 and 8 and 2 and whatever 16 times 5 is, which is 50 and 30, 80, and then divide all that by 6.
Well, that's certainly one way to do it. I'm trying to figure out if I can figure it out always. In other words, I got quite a few 1, 2s, and 3s here. I got 7 3s.
Mm-hmm.
Then I got a bunch of 4s. I got 10 4s.
Right.
So I've got 25, or excuse me, 23 numbers that are less than 4. 23 that are less than 4. I got 27 that are greater than or equal to 5.
Mm-hmm.
I would say the mean has to be less than 5.
Why less than 5
Well,
if
let me
more
give
of the
you,
numbers?
instead of 50 numbers, let me give you 5 numbers. And I'm going to weight it a little bit heavier towards the other end. So I'm going to do this. Notice that that's weighted towards the upper end.
Yes.
What's the median number here?
4.
What's the mean?
6, 12, 18 divided by 5 is going to be 3, 18 divided by,
Going to be less than 4.
Right.
That means B is bigger. Unless I can draw that in a different way, and they don't give me a whole lot of choices on how to draw it because they've given me the histogram here. There's only one way to draw it. And that is
so
with 16
you're saying,
5s and 11 6s in the column, in the sequence.
so if it was a more balanced representation, then maybe the average would be more than the median?
Could be. I would say if it was very balanced that we might not be able to tell. If it was heavily weighted towards the front end, like this, and lightly weighted in the back, like this, then I would say that the average is going to be greater than the median. But the way they have weighted it towards the 5s and 6s, well, clearly the median is 5. But the average isn't going to be 5. In other words, in my, that maybe isn't the best example to give. Maybe I should have given you 10 numbers and they should have been 1, 2, 2, 3, and then 4, and 5, 5, 5, because there's mainly 5s, and then a couple of 6s, because there's a heavy predominance of 6s. So that could be something that reflects that. Close. My concentration is on the bigger numbers, just like this. There are 16 5s, there's 11 6s. Well, if I go to find the median of this, we know that it came out to be 5. Well, the average of this isn't going to be 5. It's just not. For the average to be 5, I would need every number to be a 5, or if I have 2 6s, I can have at most 2 4s, but I got all these 1s and 2s and 3s over here. So the average is going to be less than the median if it's right skewed. If it's left skewed, it's the other way around. If there were a lot more 1s, 2s, and 3s, just 1 5 and 1 6, then the median is going to be a lower number, and the average should be a higher number. So if we had to just come up with any 10 numbers, we wouldn't be able to tell which was higher. But the fact that they give us this picture definitely spots the median at 5, without a doubt. And then the only thing we have to figure out is, can the average be above 5? Pretty impossible for the average to be above 5 when we've got 23 values below 5 and we've only got 11 values that are 1 higher than 5. No way are you getting an average of 5. Kind of hard to explain mathematically, but you get that concept?
Yes.
Okay. Let's go on. And there's a lot of problems on the GRE that are kind of hard to explain mathematically, but you can actually figure them out based on, I guess, some sort of a logic. All right.
So we have 4 minutes left, is that correct?
Yeah, we're not going to get to any hard ones because of the time left. So, I'm thinking. My first thought here is to reflect this triangle over this middle line, this PR.
Yes.
So I would end up with something that looks like that.
Yeah.
And the reason it would have to be smaller is because when I reflect it, it's root 5, and root 5 is like 2.1.
Oh.
So it's not going to look like that. I drew it kind of wrong. It's going to look like that. In other words, this distance here would be root 5, which is
Okay.
less than 3.
Right.
So I would say that makes the area of that triangle bigger,
I would agree.
the quantity B. And I would go on from there. In other words, I can kind of think that if I reflect that, maybe I would get something that looks like this. It's got to be a right angle. And now it's not so clear which is bigger. In other words, is this pink triangle bigger or is the bottom triangle bigger? And I don't know that I can necessarily tell. So nonetheless, I would not spend any more time on this.
Okay.
Definitely say that's the bigger triangle. And you can't count on what it looks like. They are drawing these to scale. Okay?
Right.
But I do know they share this side. PR
Right.
is common to both triangles. So if I did reflect that over, I know that it has to be a right angle, so that angle has to be a right angle, and this side would be root 5. This side's the same for both triangles. This side down here is 2 root 5, but that's versus a 3 and some unknown number down here.
Right.
I would just automatically go, I mean, for one thing, 3 is enough bigger than root 5. Had they said root 8, then I wouldn't be so sure. Might have to do the math. But when they say root 5, that's like 2.1. So this triangle here has to be quite a bit smaller. Now, it's still, if this point here were far enough out to the right, it could still be bigger, but I'm limited as to how far out to the right I can take that because it has to be a right angle. I got to maintain that right angle.
Right.
So, all right. Let's see if there is that's probably a good place to stop.
Okay.
Number 6 is where we got through.
Okay.
And we can pick that up on Sunday with 7. And I'm going to give this a little more thought. Maybe I can come up with a little bit more of a mathematical solution. Although I don't think you really would I wouldn't want to see you spend a lot of time doing that.
Sure.
Now, different story, if they said your life depends on this problem and this problem alone, then I would do all the math. I would figure out what PR is. Oh, that's the way to do it. Yeah, before I go, that's clearly, it didn't occur to me. We don't have to do this graphically. PR, I can figure out based on that 2 root 5 and root 5, right?
Yes.
Just by applying the Pythagorean theorem.
Right.
Okay, so whatever that is, it is, and now my thing will.
And then,
but
you could also figure out the other one too.
With that same hypotenuse versus a root 5 with that same hypotenuse, the 3's got to be bigger.
Right.
All right. Carolyn, I will talk to you on Sunday.
Okay, great. Thank you.